Thank you very much for this nice introduction. First of all, I would like to thank very much to organizers for inviting me and for their kind hospitality. Today I'm going to talk a bit about sustainable solutions towards fulfillment of EPBD goals and resilient cities. So, as we all know, in European Union a lot of buildings are very old, and about 75% of buildings have very poor energy performances. So new EPBD recast is trying to give us directions how could energy demand be lower, much lower until 2050. So the EPBD recast indicates that a major building renovation wave should help in reducing not just energy consumption, but also to contribute to the decarbonization goals of the cities. Besides all these big efforts that governments are doing over European Union, in the last decades the energy consumption, especially in the field of cooling, is constantly rising. So what can we do? We can offer a lot of different renovation measures for buildings, but as we already saw, the renovation measures should be particularly dedicated to a particular type of buildings. So in previous years, we also developed different projects with the building typology that could be very useful, especially in this field of future building renovation. Also, the national regulations are pretty much different over the European Union. So different countries have set their requirements based on EPBD, but also in accordance with their national regulation. Republic of Serbia is not a part of European Union, but it's on its way to the European Union, so we're also trying to get in this renovation wave and to set our documents according to the recast of EPBD. During the period of 2012 to 2016, about 12% of renovation rate for residential buildings was done in European Union. Is it enough? Of course not. The renovation must go faster, but of course a lot of different issues with fonts and methodologies is not solved yet. A lot of European countries still don't have the newest requirements for the methodology of calculation according to the recast of EPBD. So some of them still don't have minimal requirements for NZ buildings. And also Republic of Serbia is currently doing the harmonization of its legislation based on this new recast. In Republic of Serbia, we have more than 2 million of buildings built before the adoption of first regulation of energy efficiency in buildings. It was back in 2011. So all these buildings are very energy inefficient. But the good thing is that it's a high potential for the future renovations and the future energy savings and CO2 emission reduction as well. So what can we do? The measures are pretty much different. Here I wanted to talk today about two types of measures. One is about buildings, and the second one is more dedicated to the resilient cities. And knowing the situation about energy instability, dedication to import of energy for countries, etc. So first measure is application of green roofs of existing buildings. So how it can be essential and how it can contribute, and also floating PV systems is something that is very interesting in last year, so we are going to see some examples. First example is a typical renovation of residential building. I choose the one building which is built in a period in between of 1971 to 1980s. Why? Because in Serbia about 25% of the buildings are built in this period. Of course, the regulations were pretty much loose, so buildings had very poor energetic quality. So some of the energy efficiency measures are very typical. For example, the renovation of the thermal envelope with putting this insulation and windows replacement, but also on the example of this building, we wanted to check how the implementation of green roof can be helpful. Why we researched this? Because in Belgrade, especially in new part of the Belgrade, we have a lot of buildings which are very long, but with just a few flats. For example, 2 or 4 flats, but there is a very big area of the roof. And all these old roofs has problems with leakages, they need a renovation. So in this action of the renovation, how it's possible to upgrade the roof? Is it even possible because for some buildings, the stability checks must, of course, for every building, the stability check must be done. And then after it's possible, maybe we can implement extensional green roof. So we did analysis for a lot of buildings, but also we did some measurements for the schools, because in New Belgrade almost all schools have a flat roof and the same problems. Some of them have only 1 flat and some of them only 2. So green roof shows as one very interesting example. So what we did a major renovation with the thermal envelope with putting insulation, changing the windows, and show the example only if we renovate the roofs with putting the green roof. So here are the results for the condition of heating. We compared the base case, it's a 0 case, before the reconstruction. Then first case is if we renovate only the roof using a green roof, and then we have a comparison for the second one if we do only thermal envelope without green roof, and the third case is if we put everything. What is going to be the most beneficial? Of course, if all the measures are applied, then the primary energy can be reduced by 55%. The contribution of the green roof is not so high. It's only 6% in a heating season. But the green roof has different benefits. Also, if we compare with the cooling season, when the benefit of the green roof is about 11%. Also, if we just look these measures on the thermal envelope, it is not possible to reach NZEB. In order to reach the NZEB during the reconstruction, it is necessary to involve also some renewables, which is not done in this example. If we look the contribution in reduction of CO2 emission, if we use all the measures that I mentioned, the emission can be reduced up to 60%. But if we applied only green roof, the contribution of green roof is just 6%. But we need to be aware that green roofs has some other advantages which are very important. For example, a decrease of urban heat island effect. So on one school we measured that the temperature in summer season was about 11% lower if there is a green roof in comparison to a normal roof, which is flat. And also we measured the thermal comfort for all the rooms below the green roof. And the measurements showed that the thermal comfort in these rooms was much better in comparison to the rooms without green roof. Also, green roofs are very interesting if we look the pollinators diversity. In Belgrade we have several buildings on which we have beekeeping. So there is also one positive wave and trying to combine the beekeeping in urban areas, how it can be contributional to the environment. We have more green areas in the urban environments. Also, green roofs helps with decrease of air pollution. So we measured for that school that we observed, we measured the air pollution near the green roof, and particles, for example, 2.5 particles, 1 particles 10, all these particles were lower in the vicinity of green roof, which is very controversial, having in mind that big cities such as Belgrade have a very high pollution, especially in the winter season. And of course, as well, overall aesthetic and area is very pleasant for the human well-beings. The second example that I would like to show is the contribution of floating PV systems. So we saw previously, and you in Greece know very well, how the solar energy is contributional and how its perspective as renewables. I'm not aware, is there some floating PV systems in Greece? Floating. Do you have? No, until now. Okay, maybe after this we are going to research it together. In Serbia, we also don't have installation of floating PV systems, but we are researching the potential. Why? Because I also heard here in Greece that sometimes there is a problem with the land, with the occupancy of the land, if you are using it for the PV systems. So floating PV systems can be contributional. They have a bigger efficiency because they are underwater. Also, they reduce the algal blooming, which is important, for example, for lakes or some other type of the water which is not moving. Then also the evaporation is lower if we have the floating system on the water, which is also important. There are some examples, for example, in Spain, they have a water ponds which they use to water the olive trees, and because of the high solar effect, they have a lot of evaporation. So if they put floating systems on these ponds, they can reduce evaporation and they can get free energy that they can use in the vicinity of installation. So there are a lot of advantages. And of course, we can produce the electricity from the renewables, which is sustainable and environmental friendly. Also, it contributes to the decarbonization targets for all countries, not just European countries. And also, we know what is the problem with dependency with the import of the energy. We can see these days the problems such as this. So Serbia as an energy sector is very dependent on the fossil fuels. So we have about 71% of the fossil fuels used in our energy sector. So it will be very beneficial to include also the renewables such as floating PV systems. Our Serbian solar potential is high, not so high like in Greece, but also very beneficial, especially on the south. And here in this analysis, I looked at 6 lakes. These installations can be put also on the artificial or natural lakes, on rivers, on different mine ponds, on, as I mentioned, ponds for the watering of the olives, etc. So here we researched 6 lakes which are either artificial or natural, but the common is that they all are used already for the hydropower plants and the production for the electricity, which is beneficial because we have the electricity grid. So we can use it also as a combination with the floating system. So for these 6 lakes, we checked the PV energy outputs and also reduction on CO2 emission. We also researched a fixed system and a system with tracking application. So it is possible if we combine all these systems. We looked that on each lake we can have up to 10% of the usage of the area of the lake. It is important that, of course, not the whole area is covered, because we don't want to disturb the ecosystem. So even if we have lower area of the lake that is covered, even in that case, these systems are very beneficial, especially in the rural areas where you don't have some other opportunities. So for the PV energy output, it is possible to reach even up to 9,000 kilowatt hours per year in total for these 6 positions. And for CO2 emission reduction, it is possible to remove more than 6 tons of CO2 per year for these locations. For the future work, of course, we're going to include all the other lakes, because in Serbia we have a lot of water potential. And what can be concluded at the end? All these measures should be particularly dedicated to the building typology, to the location, and of course to the national regulation and availability. For now, we don't have ESCO companies, for example, in Serbia. We have some grants from the government, but it's still not enough to persuade the people that they need to put the money in this renovation and that it will be beneficial for them. It is very tricky. So we as teachers need to do a lot to show how all these measures will be very helpful in the future. Of course, for the floating PV systems, they are especially good for the rural areas, and also if we have very big water areas that we want to cover from any reason, if we want to lower the evaporation, or if we want to prevent the algal blooming or similar. With that, we can contribute to the green electricity production, to the decarbonization, and very important, to energy independency. Serbia, as we saw, have a high potential with our natural and artificial lakes for the development of this type of floating systems, and for the decarbonization using green electricity production. Thank you.